Okay, so lesson 2.2, creating and solving equations. So our goal is to, given a problem, in a real-world context, create and solve one variable equations. So my grandmother started walking 5 miles a day when she was 60. She's 97 now, and we don't know where the heck she is. Ha, ha. Oh, there's some smiles. Okay. Find the error. Caesar is solving the equation. 4a minus 5 equals 2a minus 3. Circle his mistake and correct it. All right, go ahead and try to find out where the mistake is. So if we look at this, just the answer shows that there may be a problem. We've done one-step equation, so we see that 2a equals 8. Do we want to solve for 2a or a? A, so we say this is multiplication, inverse operation multiplication, division. Divide by 2 both sides, a equals 4. Okay, so here's the slide with the correct answer. You can solve some of the real-world situations by translating the verbal sentences and equations and solving them. Let's remember some keywords first. So we have addition. So go ahead and write everything that's in bold for addition. So on your paper, have this as your heading, the addition part. And let's write all the bold words that mean addition. Okay, pause the video now if you're watching the video. And then write those down. 5. So we would say n plus 5. And 3 more than a number, n plus 3. Subtraction. Now take some notes on subtraction. So we have to write down difference. Difference between a number and 7. Decrease by, minus, less than. Okay, and so here is how you would translate it. Now, you don't have to write all the examples, but the one example I really need you to write is this entire thing. You need an example for this, definitely. So 5 less than a number. Because if I were to write this, I would say it was 5, then I would say less than, and I would say a number. We used n over here. Why didn't I get 5 minus n? So you have to remember that less than flips the terms. Less than flips the terms. So write this entire thing, 5 less than a number and n minus 5. Okay, pause the video now. Okay, next one. Multiplication, go ahead and start copying this. So multiplication, we have product, times, and of. So on this one, you can, unlike the less than example, you can make it to where all of these, you just write it out. So product of 6 and a number. So we know product is multiplication, so in between would be 6 times n. 5 times a number. So 5n. 1/3 of a number. Now this one's a little bit different. So 1/3 and then of and a number, we'll put n. Now if you work it out though, you know that this is n but over 1. All that is left to do is multiply across. And you could write this as really multiple ways. You could say 1/3 n, or when you multiply it across, say n over 3. Each of these ways works. Says the same thing. Okay, so pause the video and keep copying it. Division. Did you guys get those? Multiplication? Okay, division. So division, quotient of a number, and divided by. Caution! Let's see why they're saying caution. The phrase 6 less than x is translated x minus 6 and not 6 minus x. So we already addressed that when we were copying down the problems. The phrase 6 subtracted from x is translated x minus 6 and not 6 minus x. Okay, so here's another one to say about the subtracted from, how it flips the terms. So if you're unsure what we're talking about, let me break this up. Basically, I would think that 6 subtracted from x would be 6 minus x, but just like less than, it's x minus 6. You have to flip it. So add subtracted from. Translate each phrase into a variable expression. Use n for the variable. All right, go ahead and take about 5 minutes to work on this. So copy each one down and translate it. Use the list that you copied down to help you out. So pause the video and work on these 4. Make sure that you have this done if you're doing the video, and turn this in with everything else. Let's go to the next one. Translate each phrase into, yeah, the answer's on there. Okay, 5, 6, 7, and 8. Go ahead and work on these. Okay, translating sentences into equations. So 5 decreased by 4 times the number is 7. All right, so we would change it to 5 minus 4x equals 7. So same thing we've been doing in class, where we build these walls to try to figure out what each word means. So we would build the walls. 5 decreased by is minus, 4 times the number is altogether is, and 7. And with practice, you get better at breaking up the words. Translate each sentence. All right, 3 more than twice the number is 9. Try this one out. 3 more than twice a number is 9. Let's see if I can block this out. No, I wanted to fill it. So if you have it all in one long line, it makes it a little bit easier. So we have 3 more than twice the number is 9. Okay, so try that out. About 30 more seconds. About 20 more seconds. Angel, you ready? Okay. Tell me what you translated it to. 3 plus x equals 9. Okay. So look at this x part right here, right? What did you miss on there? Twice. What does twice mean? 2. So twice has 2 things going on. This word twice means 2, and it also means times. So you have to realize that when you're doing twice of something, you're multiplying. So this becomes 3 plus 2x equals 9. Okay, we're only translating, so we're not going to take the time to solve it right now. But this would be a multi-step equation, which we did in other sections. All right, next one. 2 less than 3 times the number is 9. So when you're writing it on your paper, make sure to put the 9 up here, so that way it's easier to work with. Okay, Jonna, are you ready? Ready? Yeah? Okay. So 2 less than 3 times number is 9. So hold on, let me actually get ready. I'm going to put 9 up here like the last one. Let me change this to white. Scribble this out. Okay, so we have 2. We have 2 less than 3 times a number is 9. All right, so what you put for the less than? Luis? Minus. What did we remember about less than, though? You switch it. So I'm going to put a star here because when I go back to write it neatly, I'm going to think about how should I switch that. What about 3? Genius. Times? Okay. Multiplication, a number, and is. I thought that one was going to really trip you up. All right. He's good. He's good. All right, so we have 2 minus 3n equals 9, but remember we have this star here, and we said that that means to flip it. So what should I write? Good. All right. Questions? Next one. When you create an equation to model a real-world problem, your equation may involve the distributive property. Now, I call this something else. I call it double rainbow. Oh my! Sorry, I got carried away. Let's play the video. Let's see. Recorded.
Oh my God, it's full on double rainbow all the way across the sky. Oh my God. Oh my God. Oh God. What does this mean? Oh, oh my God. Oh, oh God. It's so bright. Oh my God, it's so bright and vivid. Oh, oh, oh. It's so beautiful.
Okay, we got the point. So when you're thinking of distributive property, let's do an example problem before we move to the other one. So we would have something like 3 times x plus 2, and you would do the double rainbow, okay? 3 times x, 3x, 3 times 2, 6. This is called distributive property or double rainbow. That's what they call it in college, double rainbow. All right, 2 times the quantity 3 more than x is 9. Okay, so let's translate this together. So 2 times, this sucks. All right, 2 times the quantity 3 more than x is 9. So I had to write it out because I want you to get used to doing this. 2 times the quantity 3. So quantity is just a number. More than x is 9. Okay, Angel, what do you put for 2? Genius! Times. Woo! The quantity 3. Dang! More than? X? Oh! Is? Oh, that's a hard one. Equals. With the assist. 9. What? So we have 2 times the quantity 3 more than x is 9. But here's the thing about the quantity. You take it, that one is actually adding the 3 and the x. So that's where it gets difficult and that's why we front loaded the information of the distributive property, is because we actually want to use parentheses between the 3 and the x because of that word quantity. Okay? So this isn't going to look like 2 times 3 plus x equals 9. This is going to be 2 times the quantity 3 and x equals 9. So here are the differences. Basically, this would only multiply the 3, whereas this multiplies the 3 and the x with 2. Okay? So very simple, but you have to remember the quantity is actually adding these two together. Most of the time you'll see, instead of the quantity, the sum of, and then 3 and x. Right? Okay, try this one. Twice the number is 12 more than 5 times the number. Okay, Karen, what'd you put for twice the number? 2, and they don't get the joke. Is 12 more than 5 times the number? So, is 12 more than is plus 5 times n. Like that? Good job. Alright, so you can use n or x. It doesn't matter as long as you use the variable. They didn't specify what the variable was. Okay, try this one. The number x is 7 more than 1/4 of itself. How do I write 1/4, guys? How do I write that? 1/4. Good. So try that out. Okay. The number x is 7 more than 1/4 of itself. Angel, you ready? What'd you put?
X equals 7 plus 1/4.
Okay. And then the itself refers to x, so you put x here as well. Good job. Okay, so x equals 7 plus 1/4 x. All right, 11 more than twice x is 5 less than x. Let's skip this one. Okay, so let's go to the next thing. Translate the problem into an equation. Did not solve the problem. So now we're changing just these simple equation and expressions, and we're going to now put actual situations. So we're not going to solve this. Rudy has $15 more than Franco. Together they have $65. How much money does each have? Notice how this is formatted is that it doesn't have it all together lumped into just sentence after sentence. They tell you, make an equation, and then this is what they're looking for. So what would you put for Rudy has $15 more than Franco? What would you put for that?
15 plus x.
Okay, 15 plus, do you want to use x though? F. All right, so we're getting the F from the first letter. What about Rudy? We didn't say anything about him. And what does has mean?
put 15n plus F.
15n?
I mean, R. For Rudy.
No.
Because Rudy has 15.
Well, do it in order. So what does Rudy represent?
R.
R. What is has, guys?
Equals.
Equals. So we have R equals 15 plus F. That's your first equation. So really, now together, who is together? Who is together? Rudy and Franco, okay? So if I say Rudy and Franco, together would be plus, right? Now they have. There's that's comparison. So what comparison can we put there? So let's go over that. Whenever you see something that's comparing to something else, you have these as your comparison words, okay? Which one do you think it's going to be for they have? Equal. So equal to what? 65. So whenever you see these comparison words, then it has something to do with these. So we found out the second equation, I'm going to write it nicely, is R plus F equals 65. First equation was R equals 15 plus F. How much money does each have? So you made a system of equations. Now, we're not going to solve the problem, but I'm going to kind of set you up so when we do solve the problem, you can think about it. Basically, we know what R is, right? We know that it equals 15 plus F. I just need to plug that into the R here, solve for F, then take that F, plug it into either equation, and solve for R. Okay? But for solving it, we'll do that at a later section. Right now, we're just focusing on translating it. So this is the same stuff here, and they even show how you would plug it in. So he took the Rudy part, put F plus 15. You get 2F plus 15 equals 65. Solve for F, so on. Okay, translate this one. Try this out. It has the same kind of thing where this is your first equation, that's your second, and then this is what you would answer with both. So try this out. Okay, so you buy 5 books that each cost the same amount and a magazine, all for $67.99. You know that the magazine costs $2.99. How much does each book cost? Okay, take a second and try to translate these. So on these simple word problems like this, and simple being because every sentence represents an equation for the most part. You don't really go, after you're done with this first sentence, you don't really take information from the first most of the time to use it on the second, because we're starting out with word problems. So this first one is the equation that you want to make, then the second one. All right? So let's work this out together. You buy 5 books that each cost the same amount in a magazine, all for $67.99. We know that we're trying to find out how much each book costs. So that's our variable that we're trying to make. What do you want to use for books? What variable? B. So you buy 5 books. So we're going to say 5 books. And they each cost the same amount and a magazine. What do you want to use for magazine? M. So we're adding it together because when you buy something, you don't pick something off the shelf and say, this one's going to save me money. Everything you buy is adding, right? All for $67.99. So here's our comparison. What do you think that comparison means? Equal. Okay. I'm going to make it a little bit easier, and we're going to actually say 5b plus m equals 68. Okay. It's only 1 cent off. It makes it a lot easier if we're going to solve this. You know that the magazine costs $2.99. Okay, what's my second equation? We finished the first. Notice that the first, we only used the first sentence. What about this second equation? Very easy. So it says m equals 299. But I'm going to change that 299 to what? 3. How much does each book cost? How would you figure this out? Yeah, you would divide, but what would you do first before you divide? What would you do before you subtract? Plug it in. So your brain was working too quick. You were already at the last step. All right, so what you would do here is you have 5b plus m equals 68. I'm putting this in red because this is the part we're not focusing on yet, but you need to see it because we will focus on it. So don't check out, though. Okay, what would I do, guys? Subtract 3. Oh, why did I put the equal there? All right, subtract 3. 65. Okay, Rami? Yeah, 5b. What do you do now? Divide by what? 5. So b is equal to? I don't know. I didn't even do it yet. All right, so that would be, yeah, you got it, 13. So you have 13 books and 1 magazine for $68. Yeah, and you know, for the magazine, you knew it was only 1 because for the second equation, it tells you only bought 1. Did I do it wrong? Oh, did I say it wrong? Well, I'll edit it, okay? Nah, probably not. Any questions? What variable can we use to represent the cost of each book? Oh, actually, I'm sorry. On this, because it's from a PowerPoint, you can scroll through this and it asks all these questions. But we already went through everything. So no point in asking it twice. Could we write the equation as 299 plus 5b equals 6799? Explain why. So before we had it as 5b plus 299 equals 6799. Right? Can you write it both ways? What's the reason, guys? You're adding. What property? Hold on, Karen, don't say it. You said it earlier. Angel, you want to say it? No, not distributive. Commutative. Someone was listening. Sorry, I got pretty excited. Okay, yes, addition is commutative. Creating the equation to solve the problem. Liam paid $9 for his admission ticket to the fair and bought 15 ride tickets. He spent a total of $39 on admission and ride tickets. Write and solve an equation to determine the cost of 1 ride ticket. What's the first thing you would want to do to kind of make this easier? What do I know about each sentence? Each sentence, for the most part, will tell me an equation. Very few will be different than that. So we have Liam paid $9 for an admission ticket to the fair and bought 15 ride tickets. He spent a total of $39 on admission and ride tickets. Write and solve an equation, so this is your final one. Okay, go ahead and take a second, pause the video if you're on the video, and try to solve for this. Okay, you guys ready to work on this? Work on it together? So we have Liam paid $9 for his admission ticket. We're gonna to the fair and bought 15 ride tickets. So we're gonna make this your first sentence. He spent a total of $39. Make this your second on admission and ride tickets. And then the third is just your what you're trying to find. So if he paid $9 for his admission ticket on here, and we're trying to find the cost of one ride ticket. So looking at the third sentence it clues us into what variables we need to make. So we're going to say $9 for admission ticket, right? So we're going to say 9A. What do you think we're going to say for the next part? 15R. And what should be in between them? Plus. Now, if you had one admission ticket and you bought 15 ride tickets, right? What would this equal? What are you trying to find?
30.
Well, what happens and when you add this together? What does this represent? Yeah, what Liam paid. So we're going to put this as what Liam paid. So your L will represent what Liam paid. Everyone good so far? Now on the second sentence, he spent a total. Who's he? Liam. So Liam spent a total of $39 on admission. So we're doing a comparison. So that total is going to be equal. $39 on admission and ride tickets. So this is adding the admission and ride tickets together, right? So what should be on this side? 39. So our second sentence, they kind of throw you off because you're saying admission and ride tickets. So you might think putting A and R there, but really it's just going to be 39. So now we have Liam is at $39. And do you agree with this 9A though?
Yeah, because you could put A as 1.
So A is, yeah, good. You have to think about it. A is going to be 1 because you don't go and say, I'll take 10 admission tickets for today.
Just for yourself.
Yeah, just for me and my other personalities. Okay, so this one is just going to be 9. That's all you're going to be paying, so it's your constant. No matter what, you got to pay only one admission ticket. So 9 plus 15R. So if you look at our problem so far, this part and this part had a lot of procedural. We broke it up into 2 sentences, worked it out there. This part with the A equals 1, you really have to think in context of this situation. They don't tell you that you only buy one admission ticket. You're supposed to just understand that when you go somewhere, you want to pay for what you need to pay for, not, hey, just take all my money. I'll take 10 admission tickets. No, don't argue with me. I'll take 10. Right? So you have to think about it at this point that A equals 1. It is not given. And then we would solve for this. 39 equals 9 plus 15R. Let me change the color so you, or actually let's solve for this. So we've done 2-step equations. I want you guys to actually solve for it. Okay. So I highlighted the first and second sentence. So you have 39 equals 9 plus 15R. What's the first thing you want to move if R is your bodyguard? So R is protecting what well? 15. Okay, so what do you want to move first? The 9. So subtract 9, subtract 9. 39 minus 9? 30 equals 15R. Divide by 15. R equals 2. Good. All right, we'll finish the rest for our next class. So if you're on the videos, if you missed today, which is the 25th, and you're in the Monday, Wednesday, Friday class, then this makes up that time. But we will have the video for the next one as well.